All right, hello again. So today we're going to be talking about number classification systems. And I would like to start off just real fast. I know you guys have seen Venn diagrams before, but I like talking about what a Venn diagram is, kind of how it relates to what we're going to be doing today. So like on this real simple one, you see like you have set F on the left and set H on the right. And so if I ask the question, how many, we'll call those numbers people. So we'll say how many people are in both F and H. And I think all of you would probably say 8 because 8 is inside of both circles. Or if I said how many people are only in set F, that would be 11. Or if I said how many people are not in either one, how many people are kind of out just by themselves and not in one of the groups, and that would obviously be 7, right? So we're going to see a little more complicated Venn diagram when we talk about real numbers. But I got a couple more just that I think are kind of hilarious. So see, if you have one about zombies, robots, and aliens, I'm not sure if I agree with the whole death to humans thing of being in all three, because I think not all robots are mean, and I hope not all aliens are mean. But anyway, but that's kind of a fun one that I found. And then there's a real crazy one about the British Isles, and we'll do a couple of examples like this in class, but for the sake of the video, you can pause this and kind of quiz yourself and see which one's in which one and all that good stuff. So let's talk about real numbers. So basically what we're going to have is kind of think about this kind of Venn diagram. And I'm going to fill in all these different spots as we go through the process here of what all these different things are. The main thing I want you to see right off the bat, though, is that the little black oval and red and green, they're all kind of inside of each other. So whatever we put in this black oval is also going to be completely inside of the red, and all of those are going to be completely inside the green, and so on. The one kind of off by itself is this guy the kind of brown oval over here on the right. But we're going to talk about what all those things are. So let's kind of jump into it. So the very inside here is what we call natural numbers. And those are just our counting numbers. So that's like 1, 2, 3, 4, 5, 6, stuff like that. Nothing else. It starts at 1 and then just goes on up to infinity, one by one. Okay. Not very interesting, but it's kind of we got to start somewhere. So that's where we started with 1 and then just the normal counting numbers. We have another set right on top of that, and there's not much difference in this. So these are actually called the whole numbers, WHOLE, and the only difference between that and the counting numbers is now we have 0. Sorry. Now we have 0 in there too. Now you might be saying, why do we have another whole set just to add 0? It goes back to ancient times, the Babylonians and the Sumerians. Before they came along, nobody had 0. They didn't know what 0 was. They were kind of afraid of it, to be honest with you. Once they figured out the 0 was nothing to be afraid of, they just kind of made a new set, and then they called that the whole numbers. The next circle outside of that, so think to yourself real quick, so what are we missing still? What don't we have? Well, I think the most obvious thing we don't have are the negative numbers. So we go to the next one out, and these we call the integers. And now we have the negative whole numbers. Remember, we already have the counting numbers inside of the integers also, but now that we have the integers, now we have the negative. So I'm going to stop there real quick. So imagine if I gave the number, I don't know, 7. So 7 is a natural number and a whole number and an integer. Okay, but what if I gave you the number -7? Well, -7 is only an integer. Okay, and I hope you're starting to see kind of how these all work together. By the way, abbreviations, we use N for natural, that makes sense. W for whole also makes sense. Integers, we actually use the letter Z. I don't know why we use Z. I haven't found a good answer for that, but we do. So if you ever see Z as an abbreviation, that just means we have the integers. The next oval outside of that, basically our last one, but we have one over here to the side. We'll get to it in a second. So now we have, so again, what are we missing, right? So we're missing some fractions. So these are rational numbers. and it's any number that can be written as a fraction. Obviously, if you see a fraction, automatically it's going to be a rational number. You don't have to think about it. And again, positive or negative, it doesn't matter. If you see a decimal, there's two ways you can tell it can be written as a fraction. Either the decimal ends, like you see a specific end to it, like 0.25, or if you know that the decimal repeats. So like the most common one that repeats is 0.3 with a line over it. It's like 1/3. So any decimals that end or any decimals that repeat, and don't have to repeat one number, it might repeat a sequence of numbers over and over again. Those can all be written as fractions, okay? And those are called rational numbers, and we abbreviate that with a Q, because if you remember your elementary school days, a fancy word for a fraction is a quotient, okay? Now, our last step here is going to be the irrational numbers, and what those are, and if I can move my inset there, sorry about that. So the last set of numbers are called irrationals. And these are numbers that, they're still decimals, but they cannot be written as a fraction. Okay, so anything that's a non-perfect square, non-perfect square root, I should say, sorry. So like square root of 2, square root of 7, square root of 5, anything that you don't know the square root of right off the bat. And also our old friend, if you remember pi and from algebra 2e, those are all irrational numbers. Okay, so again, if you see a decimal that doesn't repeat, goes on forever and ever and ever, those are irrational. But again, usually it's going to be square roots that are not clean numbers, or something like pi or e, something like that. Okay, and then on top of the whole thing, then we have all of these things kind of put together are real numbers. Okay, and these are the ones that you have to know as far as classification wise. So all of these things together are all the real numbers. Okay, now there are a couple others where I'm not going to test you on these, but there are some things over here kind of away from the real numbers that are called imaginary. And again, you did these in algebra 2 with the number I. And if you remember I, the definition of I was the square root of -1. We'll get into a little more complex numbers later on in the year, but that's anything with an I in it is imaginary. And then there's these things, if you combine real and imaginary, we have these things called complex numbers. Okay? So in a nutshell, just kind of the summary of the whole thing, and I'll leave this up here. You can pause the video, take a picture if you need to. But those are kind of your summary of the different classifications of real numbers. Okay? So lastly, how do we classify these things? So here's just a few examples. You can make a table. I think this is the easiest thing to do. And then once you check off one box, you're going to check off the other boxes to the right. So like on -10, which one does -10 fall into first? Well, we know it's an integer because it's negative. If it's negative, it's not going to be whole or natural ever. So it's an integer, and then automatically, whoops, kind of lied to you there. So it's not an irrational either. Irrational is kind of its own thing. So it's integer, rational, and real. Okay. And again, you might be saying, well, wait a minute, it's not a fraction, but it can be written as 1 because it's -10/1. Okay. 1/3. Again, 1/3 automatically a fraction, so it's rational and real. -7.2, notice the decimal ends, there's nothing else to it, right? So if the decimal ends, then it's rational and automatically real. The square root of 2, again, we don't know if it's some kind of decimal, but it goes on forever and ever. Again, not a clean square root, so it's irrational and real. And then 39, well, we can count to 39 just using our fingers and toes and maybe someone else's fingers and toes. But that's natural, and then it's everything else. Again, skip irrational, except unless it's irrational. Kind of go from there. Okay? So that's kind of your classification of real numbers. Hope that helped out a little bit. Practice on your own. You can have a short assignment to do. And until next time, stay safe.